I've met very few people who have obsessed so much about something as I did with AI. Most people use click products to make basic platformers or are happy to stick to simple, pre-scripted AI, but I wanted to go further. It was a true holy grail of mine to make AI that wasn't just a challenge, but that could also react to situations that it hadn't even been programmed for. I've also included a little space game in my game collection that I made at around the same time as Dragon Mine. It features a friendly ship since I found most shoot 'em up games to be a little bit lonely. Check the description for the download. I will not be upset if this video doesn't interest you, but for the 10 or so of you who are keen on making your own AI in games that you make on Fusion, this video could save you hundreds of hours. I will cover my attempts at making convincing artificial intelligence in my games, the problems I faced, and the shortcuts I used. There are hints to this obsession in a lot of my earlier games. In the 2003 version of Dragon Mine, just after the first mission, you'll see Louise who can move in any direction while facing any other while looking wherever she pleases. She was inspired by early videos of Half-Life 2 where Alex would seemingly observe the world around her. I wanted Louise to accompany you through the levels, spotting important details and helping you to solve problems. But I never did it. I was also inspired by a level in Sven Co-op. You could spawn NPCs in a pit and they'd fight against each other. If you've tried the later version of Dragon Mine, you might have seen Bane and Yo-Yo Man. Bane is a gung-ho, all guns blazing kind of fighter, while Yo-Yo Man relies on stealth and precision. I would get them to fight each other in my tests. I always wanted Yo-Yo Man to win. It's sad that in the version that you play, Yo-Yo Man only follows a path while Bane literally runs towards enemies firing hundreds of bullets, because in most other versions of Dragon Mine that I made, they used a complex mixture of scripted and spontaneous actions. Perhaps it's because of that I never got around to making the game itself. But be warned, don't just make a game because you want to have the best AI ever. I find that the reason for wanting to make a game majorly determines whether you'll finish it or not. The projects where I've been thinking about a tiny, very specific gameplay mechanic tend to be the games that I don't complete. I went through obsessions with guns, lighting, and breakable objects, but my biggest downfall was AI. I was convinced that if I could make the AI good and hard enough, then the game would be a success. With my earliest games, I would use scripted scenes. If you shoot an enemy in one area, then they'll run to another and then we'll start firing shots at you. Stuff like that. I'd make a level or two in this format before realising that I'd have to hand code every event in the entire game, and that I just couldn't be bothered. So I switched to bouncy ball movement. An excellent decision and one that I still use. The idea behind it is that the characters will bounce about the screen. They don't have to avoid walls, they just deflect off them. But to make it interesting, they also had to look as though they were thinking about their actions. With early games like Doom of the World 1 and 2, I used invisible objects that would bounce about the screen. When they collided with a character, it would make them perform a random action, like stopping, starting, or changing direction. Just like the bouncy ball movement, although it's simple, it works surprisingly well. However, invisible bouncy objects use up a lot of processing power and can potentially miss certain people if you don't use the correct number of objects. So I switched to random numbers, where every second it would choose a random number between 1 and 10. If it's 1, they stop, if it's 2, they go, and if it's 3, they change direction. It's a less intuitive way of doing things since it's easier to imagine invisible stop objects bouncing about the screen, but this new method is without a doubt much better. But it still doesn't lead to good gameplay. With Dragon Mine, I began experimenting with sight. How can you tell if an enemy can see your person? I made enemies shoot out invisible sight objects towards you. If they hit something solid like a wall, the sight object would be destroyed. If it hits you, the enemy shoots. But here's the big problem. How does it know which guard has seen you? A sight object is just that, an object that hits you. It has no memory of who fired it in the first place. This wasn't something that I solved with Dragon Mine, so you'll find that if one guard can see you, everybody in the entire level will suddenly wall hack and shoot towards you. It's a bit annoying, but you'll notice that it hardly matters in the grand scale of things. Perhaps my greatest achievement with AI was Dragon Mine 2, a game that I never completed. By this point, my obsession had changed from AI to completing the most advanced game engine ever seen in the Games Factory. I worked at this game for years, forever remaking and improving on what I had done before. I kept going until I had AI good enough to do anything that I wanted it to do. Instead of shooting sight objects towards you, they would instead fire in any direction in front of the guard. This meant that they didn't have tunnel vision. They'd spot bodies and anything else in front of them. It meant that they were even capable, in theory, of shooting explosive pipes that were close enough to the player. It opened up a lot of opportunities that I never got around to implementing. Firing invisible sight objects is an inelegant solution. It would be far better just to test the line of sight directly, but this was something I was never happy with. My friend Tom managed to discover a way of doing this, and sure enough it was more efficient, and yet I never liked using it since I didn't fully visualise how it was working in my head. Going back to the invisible things bouncing about the screen earlier, they were silly, but anybody who could see it in motion knew exactly how it worked. With line of sight tests, they struggle to tell which guard sees what, and it's harder to have peripheral vision since they won't test the vision between themselves and, say, dead bodies and exploding pipes. I don't doubt that it's possible, but I never considered it worth the weeks of suffering implementing a system like that would cause me. In my opinion, invisible sight objects are an example of, if it ain't broke, don't fix it. In Dragon Arrow Mine 1, the moment the guards can't see you anymore, they'll run about as though they'd forgotten they had ever seen you. In the second game, I made it place a last known location object every time they spotted you. Even if they couldn't see you, they would instead rush towards this object, which gave the impression that they remembered where they saw you last and were scouting out that location. There were many small tricks that I used in Dragon Arrow Mine 2 that I still use to this day. I might have wasted years of game development time, but I amassed an advanced knowledge of tricks and shortcuts which would aid me in later games so that I could boldly go where other developers simply couldn't. How did I avoid the wall-hacking guards from Dragon Arrow Mine? Every guard was assigned a unique number, and any sight objects created by them would also have the same one. This meant that, once the sight object hit the player, the game knew which guard it had come from. It took me years to get the system working since the game makers struggle to tell the difference between specific and general events. For example, if I made the event give guards a random number, it would only give one of them the number, or it would give them all the same number, or it would repeatedly change one guard's random number and not give the other ones a value. To get around this problem, I had to make the event say, pick one of the guards who hasn't already had a value assigned to them and give them a random number. Let's give you some more horrible examples of how AI can go wrong. If you give them all a random number, there's a chance that two could have the same value, just by chance. There are always ways around these problems, but you have to decide whether it's worth the hassle, like using random spread values or simply assigning values one higher than the one before. I never bothered since I seemed to get off on the slight chance of things going horribly wrong. In fact, I intentionally began coding horrible things in later games. In my game Scrumpy Ninja, there's a 1 in 1,000 chance of a terrifying homing window spawning and chasing your character until it got them. I've never had it happen to me, but I await the day that somebody claims it's happened to them and everybody else dismisses them as an attention seeker. I have problems. The biggest challenge for me was always pathfinding, because in my mind I could see ways of getting it to work, but it never did. Do you know how hard it is to get enemies from one part of a level to another? I'd place nodes in each room. At the start of the level, they'd see which others they could see and would build a web of information. If enemies were near node 1 but wanted to get to node 3, how could I tell them that they had to go through node 2 first? I could design that by hand, which is what I did with Doom of the World 3, where invisible nodes in the level would tell them which way to head if they were attacking or defending, but my main goal was always to get them to figure it out themselves. You know how sometimes you struggle to do something and after a night's sleep you try again and can do it easily? I find that age does the same thing. I can try for months to make something and fail, only to come back a year or so later and to find it easy. Time and time again I've done this with AI. Earlier this year I came back to the pathfinding challenge and beat it by using a large table that pre-calculated the fastest routes between each node before the level even loaded. It wasn't a tidy solution, but was one that never even occurred to me back in the days when I was struggling with AI. I didn't even make it for a game. It was just to conclude a challenge that had beaten me for over a decade. I'm sure that I'll find a use for that knowledge at some point. It's funny, but also kind of sad that I spent more time working on AI than I did with anything else in game design, and yet it's the one thing that hasn't been included in any of my finished games. The best has got to be in Deathgiver 2, a game that I'll be covering in the next video in this series, but you'll struggle to find anything clever in that game. I wonder if I'll always be able to wait until later and find things easier, or if there comes a point where it starts getting harder again. I'm in my mid-20s now and it hasn't happened yet. So, for all of you out there struggling to make your dream project, try sleeping on it. And failing that, do something else for a couple of years.
The next thing I remember is that I was alive. But oh no, I was captured and was being tortured. Luckily the bad man stopped and left the room, and I was able to escape. Luckily the bad man